Hello students, welcome to my YouTube channel. In this video lecture, we are going to continue next questions from mid-course test from Oxford General Navigation book. In the previous lecture, we solved first 10 questions. In this video lecture, we will be solving the next 10 questions. So let's begin with question number 11. Static air temperature is plus 35 degrees Celsius. That means static air temperature means ambient air temperature. Pressure altitude is equal to 5000 feet. What is true altitude? Now this pressure altitude is inclusive of barometric pressure, barometric error of altimeter. Okay, so there are altimeters. Altimeter is subject to two errors out of many errors. The first one is barometric error or pressure error. That is when you fly from a low pressure to high pressure to low pressure. And the second error is temperature error. Means when you fly from ISA temperature conditions to conditions which are colder than ISA, or from ISA air mass to an air mass which is warmer than ISA. So in both cases, your altimeter will behave beyond or behave. So in both cases, this altimeter will behave not according to expectations. Basically, okay, it will give erratic readings or wrong readings. It tends to give wrong readings. The difference between indicated altitude and true altitude is there. So when you fly from high pressure region to low pressure region, true altitude of aircraft is less than indicated altitude. When you fly from hot temperature region to cold, meaning from an air mass which is hotter than ISA or warmer than ISA to an air mass which is colder than ISA, again true altitude will be less than indicated altitude. Opposite will be the case when you fly from low pressure region to a high pressure region and colder air mass to a warmer air mass. Now over here pressure altitude is corrected for barometric error. We have to do the remaining correction which is temperature correction. Now the formula is temperature error correction. Formula is 4 degrees Celsius into pressure altitude into ISA deviation. Okay, so now let's find out ISA temperature at 5000 feet. So ISA temperature at 5000 feet will be 15 degrees Celsius minus 2 into 5, which is 15 minus 10, that is plus 5 degrees Celsius. So this should be the ISA temperature according to ISA at 5000 feet. But actual temperature is what? Actual temperature is plus 35 degrees Celsius. Okay, so that means this ISA temperature is different, or static air temperature is different from ISA temperature. There is deviation between them. So ISA deviation is static air temperature or ambient temperature minus ISA temperature. That is equal to 35 minus 5, which is equal to 30 degree Celsius. This is the deviation between ISA temperature and ambient temperature. Substitute the values. 4 into 30. Pressure altitude is 5000 feet. So just write 5. Okay. That is equal to 600 feet. Right. 4 into 30. 4 to the 120. And 120 into 5. 600 feet. So 600 feet is the correction. So now your true altitude will be equal to pressure altitude plus this correction, or it can be true altitude equals to pressure altitude minus correction. So over here, look at this. In this case, static air temperature is more than ISA temperature, right? So when your aircraft flies from ISA conditions into an air mass which is warmer than ISA. In this case, it is warmer by 30 degrees Celsius. So into warmer air mass. Whenever you fly into warmer conditions, true altitude of your aircraft will be more than indicated altitude. In this case, true altitude will be more than indicated altitude, which is 5000 feet as given in the question. So if true altitude is more than 5000 feet, we will have to use this formula, the addition formula, right? So substitute the values. Pressure altitude equals to 5000 and the correction is 600. So true altitude will be 5600 feet. 5600 feet. Okay. So correction is 600 plus 600 positive. So use this. If it is minus 600, use this. Pressure altitude minus 600. So this is your final answer. True altitude equals to 5600 feet. So 11 is 5550, okay, or 5550 is nothing but 5600 feet approximately. So the closest option is option Bravo. Next, question 13, correction, question 12. Given that the value of ellipticity of the Earth is 1 by 297 and the semi-major axis means they are talking about equatorial axis measured at the axis of the equator is so and so. What is the semi-major axis of the Earth measured at the axis of the poles? Now we all know due to the compression of the Earth, polar diameter less than equatorial diameter. Polar diameter is less than equatorial diameter. By what value? By 23 nautical miles or 43 kilometers or some 27 statute miles. Also by this ratio by 1 by 297. Okay, that is 0.3%. So that means polar diameter will be less than equatorial diameter. So equatorial diameter by what amount? By 1 by 297 by 1 by 297 of equatorial diameter. Now equatorial diameter is 6378.4. 6378.4 minus 1 by 297 into 6378.4. 6378.4 minus 6378.4 divided by 297, which is 21.47. So I'm just writing 21.4. Now 6378.4 minus 21.4 is equal to 6357 kilometers. So this is your final answer. The measurement of polar axis okay, will be equal to 6357 kilometer when the measurement of equatorial axis is 6378 kilometer. Simple. Next. Question number 13. You plan to fly a track or course of 348 through. Drift is 17° port. Variation is given. Deviation is also given. What compass heading will you fly? Now first we will find true heading from this true track of 348 degree using the drift given. Okay. Now we all know when drift is whenever there is a port drift, the heading of aircraft will be more than its track. In this question, drift is 17°, track is 348 degree. So heading will be more than 348 degree by 70. So 348 plus 17 is 365. Nothing but 005 degrees. That means the heading of aircraft is 005 degree on a track of 348 degree true. So I'll write here true, variation, magnetic, deviation, compass. So now true heading is what? 005. Variation is 32 west. Now with variation west, magnetic will be best, meaning magnetic direction will be more than true direction. So 32 plus 5 is 37, so 037. Deviation is 4 east. Deviation east, compass will be least, meaning compass direction less than magnetic direction. So 37 minus 433 degrees. Okay. So this is your final answer. Compass heading is 03. So select the option which has this value 03. Question 14. At a specific location, the value of magnetic variation is what? It depends on the value of magnetic heading. Wrong. It depends on the value of true heading. Wrong. Varies slowly over time. Depends on the type of compass installed. So that is also wrong. Option Charlie is the correct option. Actual question from chapter number 3, Earth magnetism. Magnetic variation at a particular location will keep on changing, but the change is very, very slow. Remember. Next, question 15. At the magnetic equator, dip is 0, variation is 0, deviation is 0, the isogonal line is an ergonic line. So the correct option will be option A. Now what is dip? Dip is nothing but the angle between the horizontal component of the Earth magnetic field and the vertical component. Magnetic equator, what happens? Horizontal component is maximum and vertical component is nil or zero. Therefore, there is no angle or 0 degree angle between the horizontal component of the Earth magnetic field and vertical component. Opposite is the case at either North Pole or South Pole. Okay. So therefore dip is 0 at the magnetic equator. Variation cannot be 0. Deviation is a property, is a characteristic of aircraft. Okay, and isogonal line is an ergonic line, that is also wrong. Isogonal line is a line joining places of equal magnetic variation. Ergonic line is a line joining place of zero magnetic variation. Next, 16. The value of variation on a chart changes with time. Yes, it does. This is due to what phenomenon? Movement of the magnetic poles causing an increase. Wrong. Movement of the poles can also decrease the variation, not necessarily increase. Increase in the magnetic field causing an increase. Wrong. Reduction in the field causing a decrease. Wrong. Not necessarily. Movement of the poles. Yes, which can cause either increase or decrease. So this is the delta is the correct option. Another factual question from chapter 3. Question 17. One purpose of a compass calibration is to reduce the difference, if any, between what two directions. So, compass calibration is nothing but swinging, okay, and it reduces the difference between magnetic north and compass north. So, the correct option will be option Bravo, compass north and magnetic north. Next, question 18. True track is there, variation is there, deviation, drift is there. What is compass heading? So we will convert this true track into true heading first. We know whenever there is a starboard drift or right drift, heading is less than track. Now with a drift of 10 degrees starboard, heading will be less than 352. So heading will be equal to 352 minus 10, which is 342 degrees. Okay. So now true, variation, magnetic, deviation, and compass. Now true heading is 342, variation is 11 west. Now with variation west, magnetic is west, meaning magnetic direction will be more than true direction. So 342 plus 11 is 353. Deviation is minus 5, meaning 5 degree west. Now deviation west, compass will be west. Compass will be more than magnetic. So 353 plus 5 is 358. So the final answer is, what is heading, compass heading? It is 358. Next, question 19. Pressure altitude is 27,000. Outside temperature minus 35 Celsius. Mach number, winds, track. Now what is drift and what is ground speed? So let's use CX3 find out to find out drift and ground speed. But in CX3 you will have to put the value of TAS in order to find ground speed. Now in this question, TAS is not given to you directly, but they have given a Mach number and extra information like pressure, altitude, and outside air temperature. We all know that Mach number is equal to true airspeed with respect to local speed of sound. So true airspeed will be equal to local speed of sound multiplied by Mach number. Local speed of sound is nothing but 39.17 square root of temperature in kelvins into Mach number. Okay, so Mach number is 0.45. Write it here. Now temperature. Now temperature at, I say temperature at 87,000 feet will be something. It's given in the question, static air temperature or outside air temperature minus 35 degrees Celsius. Convert this into Kelvin. Minus 35 plus 273, which is 238 Kelvin. Substitute it here. 39.17 square root of 238. Square root of 238 is 15.42 something. So 39.17 into 15.42 is 604. That means local speed of sound at this altitude where temperature is minus 35 Celsius is 604 knots. Now multiply 604 into 0.45. You get 272. That means the true airspeed of aircraft is 272 knots. Let's substitute it here. 272. Force is force is 200. True again. Speed 270/85. Yeah. So ground speed is 230.904, approximately 231 knots. Okay. So ground speed is 231 knots. And true heading is 217. True heading is 217. Course is 200. Now drift. What will be the drift? We all know when heading is more than course, with heading more than course, with heading more than course, you get port drift. So the answer will be, what is drift? It is a port drift of, in this case, 7 degrees. 217 minus 200, 7 degrees, and a ground speed of 231 knots. Important question, and this is how you solve it. Next, question 20. You plan to take off from Saudi Arabia where elevation is 6,500. Temperature, outside temperature is plus 25. What is your density altitude? Density altitude equals to pressure altitude plus 120 into ISA deviation. ISA deviation is equal to your ambient temperature minus ISA temperature. Now ambient temperature here is 25. What will be the ISA temperature at 6,500 feet? ISA temperature at 6,500 feet will be 15 minus 2 into 6.5. 6,500 divided by 1,000. So 2 into 6.5 is 13. So 15 minus 13 is equal to 2 degrees Celsius. So 25 minus 2, which is 23. Okay, so ISA deviation is plus 23. That means outside temperature is 23 degrees Celsius warmer than ISA temperature. Therefore, density altitude will be more than pressure altitude. Pressure altitude plus 120 into ISA deviation. So 6,500 plus 120 into 23, 2760 is 9,260. So the correct answer is 9,260. With this question, we come to the end of this lecture. I hope you have understood all the 10 questions I have done today. I also suggest that you all solve the questions which I have done which I did in the previous lecture, and then the questions which I have done here. In the next video lecture, we will do the next 10 questions. So I urge you all to be present in that video lecture, to watch that video lecture. And with that, keep in touch with studies. If you have any doubts, questions, let me know in the comment box. Do subscribe to this channel if you haven't yet and share this video with all your friends. Don't forget to like this video lecture. It will mean a lot to me. All the best. See you next time.